Hello, this is Varun, and today in real numbers we will start with our next topic, which is fundamental theorem of arithmetics. According to fundamental theorem of arithmetics, every composite number can be expressed as a product of primes, and this prime factorization is unique apart from the order in which the prime factors occur. Well students, we know that 50 is a composite number which can be written as 2 into 5 into 5. Means we can express 50 as a product of 2, 5 and 5. In the same way, 60 is also a composite number which can be expressed as a product of 2 into 2 into 3 into 5. Here 2, 5 and 5 they are prime, and in this case 2, 2, 3 and 5 they all are prime numbers. If we multiply these numbers by changing their order, that is if we multiply 2 into 3 into 5 into 2, or we multiply them in the order of 2 into 2 into 5 into 3, or in the order of 5 into 2 into 2 into 3. In every case, their product will remain 60. This is what the fundamental theorem of arithmetics tells, that every composite number can be expressed as a product of primes, as we express 60 in the product of primes. And this prime factorization is unique, means whatsoever the order of multiplication of these prime factors be, they will always multiply to 60, means their product will always remain 60. Same thing we can test for 50 as well. Students, next we have the question, can 6 power n end with the digit 0 when n is any natural number? Well students, we will do this question by using fundamental theorem of arithmetics. But before moving on, you need to mind that only those numbers can end with the digit 0 whose prime factors contain 2 and 5. Means those numbers whose prime factors contains both 2 and 5, only they can end with the digit 0. Otherwise, they can't. If the prime factors of the number contain 2, 5 and any other prime number as well, even then it will end with 0, because those composite numbers whose prime factors contain 2 and 5 and any other prime number, they will definitely end with the digit 0. As you can see here that prime factorization of 60 is 2, 2, 3 and 5. Prime factors of 60 are 2 times 2, 1 is 5 and 1 is 3. As it contains both 5 and 2, other than 5 and 2, it contains 3 as well, but we are not bothered with other factors. We are just concerned with 2 and 5. If 2 and 5 are present, then they can end with the digit 0, otherwise they can never end with the digit 0. We can write 6 as 2 into 3. The whole power n will remain as it is. It can further be written as 2 power n into 3 power n. So you can see that prime factors of 6 power n, they do not contain 5, they contain 2, but they do not contain 5. 5 is not there, so it can never end with the digit 0. But we have to answer it with the reference of fundamental theorem of arithmetics. So we will write. So our presentation will be, for 6 power n to end with 0, its prime factors must contain 5 also, but it is not possible, because we have seen that 6 power n equals to 2 power n into 3 power n, and uniqueness of fundamental theorem of arithmetics guarantees that there are no other primes in the factorization of 6 power n, so it can never end with 0. If we have the question that can 4 power n and with the digit 0, where n is any natural number. Again, we will go for the prime factorization of 4, and that will be 2 power 2 the whole power n, that is 2 power 2n. Again, it do not contain 5, so we will write the same things and we will say no, even it can't end with the digit 0. Now let us take one more example. If we have the question that can 6 power n into 5 power m and with the digit 0. So we will go for 6 power n can be written as 2 power n into 3 power n, and 5 power m will remain as it is. Now you can see that in this, the prime factorization of this whole number contains both 2 and 5. Since both 2 and 5 are present, so yes, it can end with the digit 0. And in this case, we don't need to write this whole thing. We will just write yes. We will write this thing when it is not. In case it can end with 0, then we will just write yes. Thank you. Next, in real numbers, let us discuss one more type of problems. We may have the questions like, is 7 into 11 into 13 plus 13 composite, and why? Well students, in the beginning of this chapter, we did the concept of prime numbers and composite numbers. We know that prime numbers are those which have only two factors. One is 1 and number itself. Whereas composite numbers are those which have more than two factors. That is 1, number itself, and any other factor. And to check whether this is composite or not, we will try to find its factors. If this number has any factor other than 1 and number itself, then it will be composite, otherwise it will not be composite. And we know that 7 into 11 into 13 plus 13 can be written as, from this and this we can take 13 common by using distributive property, and in the bracket we left with 7 into 11 plus 1. Since we are able to take 13 common, it means 13 is factor of this whole number. 13 is factor of this given number. As this number has at least 3 factors, one is number itself, other is 1, and third we have found 13. It may have other factors as well, but yes, we have found that 13 is its factor. As this number has at least 3 factors, so yes, it is composite. So we will write, as given number is divisible by 13, so it is composite. That's it.